Now, I just wanted to show you something and how this is set up. In this last one, we'll talk about making a confidence interval estimate again for the standard deviation. Because we're doing something for the standard deviation, that is again how we know that we are going to use chi-squared. So let's start by drawing our chi-squared picture, where we're starting at 0. And remember, because we're building a confidence interval, we need two ends. We've got a chi-squared on the left we need and a chi-squared on the right that we need. And we have a level of confidence of, let's see, 95%, and that's going to go in our middle of our picture. So it'll be this area in between our two critical values that we're looking for. So we can go ahead and fill that in as 0.95. So our 0.95 here is going in the middle. That means the other 5% is going to go between both tails, which means that each tail individually should be half of that 0.05, which is going to be 0.025. Okay, well, let's work on finding this first critical value on the right here. So how do we do that? To find the critical value on the right here, I need an area to the right. So I'll start by looking at the area to the right, which we just found was the 0.025. So we've got our 0.025 as an area to the right. We'll follow that down. We also need a degrees of freedom. Remember, that's your sample size minus 1. Well, they didn't give us the sample size, but they did give us a list of data. Our list of data, if we go back, let's see how many entries there were in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our n was 10, which means our degrees of freedom is actually going to be 1 less than that, which is going to be 9. So if we go back to our table, we're going to use a degrees of freedom of 9. And that means that our first critical value, the one on the right, is going to be the 19.023. So that will be our first critical value. The one on the right is the 19.023. We are halfway done finding our critical values. Now we need the one on the left. Remember, the one on the left is a little bit more complicated because it needs the full area to the right again, which means you need the 0.05 and, or sorry, the 0.025 and the 0.95 put together. Well, the 0.95 added to the 0.025 is actually going to give us 0.975. We'll still use the same degrees of freedom. That's not going to change. So we've got our new area, the 0.975 to the right, which gives us a chi-squared on the left of 2.700 for our chi-squared on the left. So we've got both critical values now, the one on the left and the one on the right. Now remember, let's look at our formula for finding the confidence interval for our standard deviation. It starts out with the following. It starts out with a square root. Then we start out with next n minus 1. And s squared. And divided by a chi-squared from the right side on the left, and the chi-squared from the right side, from the left side on the right side. And let's see how this goes. Well, we've got our n minus 1. That's our degrees of freedom. Our n was 10, so our degrees of freedom are going to be 9. So we can go ahead and fill that part in. That is all set up. So I can fill in the 9. We've got our chi-squared from the right. It was our 19.023. We just found that from our table. And then we have our chi-squared from the left from our table of 2.700. The only thing I'm not seeing anywhere given to us in the problem is our S, our sample standard deviation. There's a reason why. They did give us a data set. And so what we need to do is back what we did in chapter 3, is enter in our data set and go find the standard deviation using that one variable stats option on our calculator. So if you remember how to get there, remember you press your stats key, then you choose edit, which is your first option, enter in all your data. That's what you're going to do first. And then second, you have to hit the stat key again and arrow over to calculate. And you choose the first option, one variable stats. Again, this was back in chapter 3. And you press enter and you're looking for the SX, the sample standard deviation. And you're going to have to round it. It's not pretty. So what we'll use is the 0.48. So this means our sample standard deviation is 0.48. And we'll go back to our formula and we'll use that 0.48 in our formula. Remember that according to our formula, what are we supposed to do to that 0.48, the standard deviation? We're supposed to square it. And order of operations is going to make sure that we do the squaring first. Then we'll multiply by the 9, and then we'll divide by our chi-squared value, and then we'll take the square root at the very end. So let's see what happens. Let's wait for the square root. Let's see what ends up being underneath the square root first. Let's do that squaring, multiplying, and then dividing first. And what we'll end up with is 0.11 and 0.77. That's without taking the square root. And then we'll take the square root in our last step. And let's see what our confidence interval ends up being. It ends up being 0.33 and 0.88. So our confidence interval is the 0.33 and 0.88. That is our final answer for our confidence interval for the population standard deviation. So, and what you can see is, yes, most of this we can't do by hand, but there's nothing really new other than the new picture of how the chi-squared picture works. Everything still works the same way that we did before. It's just the calculator can't do quite as much for us.